Hi, so today's lesson is 9.6 position to term sequences. The objectives for today: to generate terms of a sequence using a position to term rule and to use linear expressions to describe the nth term of simple sequences. Prior knowledge needed for today's lesson then. You should be able to substitute values into simple expressions. So for example, if we were told n equals 3 and our expression is 2n plus 1, substituting n for 3 would give us 2 times 3 plus 1, which using BIDMAS would equal 7. You should also be able to find the next terms in a term-to-term sequence. So given the sequence 2, 5, 8, 11, the next two terms would be 14 and 17. So you would do that by finding the rule to get from 2 to 5, which is plus 3, 5 to 8, which is plus 3, and 8 to 11, which is plus 3, and then adding 3 to 11 to get the 14, and 3 to the 14 to get the 17. Things you'll need for this lesson then: you need your maths book or some paper to write on, a pen or a pencil, and you may want to have your calculator handy for any of the trickier questions. Okay, so today we're going to have a look at position to term rule then. So each term in sequence has a position. So the first term is in position 1, the second term in position 2, etc. And the position to term rule tells us how to work out a term in a sequence when you know its position. Okay, so it's really useful if we don't just want the first few numbers in a sequence, but we want a number that's further along in the sequence without writing out a whole sequence. So to work out the first four terms of the sequence then, our sequence here we're told is the position number plus 6. So we take position number 1 and we add 6, which gives us 7. For number 2 in the list, we would do the position number 2 plus 6, which is 8. Then 3 plus 6 is 9. 4 plus 6 is 10. So the first four terms in this sequence are 7, 8, 9, and 10. Let's have a look at another one. This time the rule we're given then is 2 times the position number minus 3. So again, we're going to find the first four terms, so the first four positions. So we take 2 and we're going to times it by position number 1. So 2 times 1, so we do that first, is 2, minus 3 is equal to minus 1. For position 2, we're going to do 2 times 2, which is 4, minus 3, which is 1. Position 3 is 2 times 3 minus 3, which comes to 2. And position 4 is 2 times 4 minus 3, which equals 5. So the first four terms in this sequence are minus 1, 1, 2, and 5. So you can see each time we've simply swapped position number for the number we want. And in this case, we wanted the first four, so that's numbers 1, 2, 3, and then 4. Okay, so your turn then. So again, we want the first four terms in each sequence. You've been given two different ones here. You've got 3 times the position number, and you've got 2 times the position number plus 1. Pause the video now and have a go at those. Okay, let's have a look at the answer for these then. So 3 times the position number. So we're going to do 3 times position 1, which is 3. Then 3 times 2 is 6. 3 times 3 is 9. And 3 times 4 is 12. So the first four terms in this sequence are 3, 6, 9, and 12. For the second one, remember the position number again. We're going to do the first four. So we're going to swap position number for 1, 2, 3, then 4. So we've got 2 times 1 is 2. Plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. And 2 times 4 is 8, plus 1 is 9. So the first four terms in this sequence are 3, 5, 7, and 9. Okay, make sure you've marked those and that you're happy. We've simply swapped the position number for numbers 1, 2, 3, and 4 for the first four terms. Okay. Using the nth term rule then. So the nth term rule is a position to term rule that helps us to work out the term in any position in the sequence. So as well as just finding the first few terms, we can work out terms further down the line without writing out the whole sequence. So this is going to be quite useful for us. So the nth term of a sequence is 3n plus 1. So remember, n simply stands for position number. So where we used the words position number in the previous slides, we're now putting in the letter n instead. So to work out the first 5 terms, we're going to swap n for 1, then 2, then 3, then 4, then 5. So we'll do exactly the same as we did, because n is our position number. So if n is equal to 1, position 1, we're going to do 3 times 1 is 3, plus 1 is 4. Our next one would be when n is 2. So 3 times 2 is 6, plus 1 is 7. And we do that for each one. So our third number, we swap n for 3. Then we're going to swap n for 4. And we swap n for 5. So these are our position numbers, 1, 2, 3, 4, and 5. And we've simply swapped the n for those positions, remembering that 3n means 3 multiplied by n. So the first 5 terms in this sequence are 4, 7, 10, 13, and 16. Okay, you might also want to put this in a table instead. So another way of seeing it, I've got my position numbers across the top. So I'm 1, 2, 3, 4, and 5. And I simply put them in. 3 times 1 is 3, plus 1 is 4. 7, 10, 13, and 16. So you might want to record them in a table instead. Okay, so why do we use this nth term then? Well, it means I don't have to just find those first 5 terms. I can find a term anywhere along the sequence I want. So if we know that the nth term rule is 2n plus 3 and we want the 10th term, we simply substitute the letter n for the number 10 because that's our position number. So if we substitute n for 10, we've got 2n, remember 2 times n, so that's 2 times 10 plus 3. Making sure we follow BIDMAS means we do the multiplying first, so 2 times 10 is 20, plus 3 is 23. So I haven't had to find all the terms at the beginning to find the 10th one, I can just find the 10th one straight away. Let's try another one then. So our rule is 5n minus 4, so that's 5 times n minus 4, and we want the 50th term. So we're going to swap n for 50. So we have 5 times 50 minus 4, again following BIDMAS, 5 times 50 is 250 minus 4 gives us 246. One more. This term, the rule is 20 minus 3n, so that's 20 minus 3 times our position number, and we want the 5th term. So we're going to swap n for 5. So we get 20 minus 3 times 5. Now we do need to remember to follow BIDMAS here. BIDMAS as we multiply before we do subtraction. So we do the 3 times 5 is 15. 20 minus 15 is 5. So 5 is the 5th term in this sequence. Okay, so your turn to have a go. So we've got a table there and we're asked to fill in the first 5 positions of the sequence 5n, and then what's the 10th term of the sequence, and then another sequence n minus 3, work out the first 5 terms and find the 15th term in the sequence. Pause the video, have a go now. Okay, so for the first one then, 5n, well, if n is 1, I need to do 5 times 1 first of all, which is 5. Then we're going to swap n for 2, so 5 times 2 is 10. Then 5 times 3, 5 times 4, and 5 times 5. If I want to find the 10th term, I'm going to swap n for 10. So we've got to do 5 times 10, which is 50. For our second one then, we've got the position number minus 3. So our position number here is 1. So I have to do 1 minus 3. 1 minus 3 is minus 2. Then 2 minus 3, which is minus 1. 3 minus 3 is 0. 4 minus 3 is 1. And 5 minus 3 is 2. And we're asked now for the 15th term. So we're going to swap n for 15. So we get 15 minus 3, which is 12. Okay, so we can see how useful this is for finding these terms further down the list without having to continue the sequence on and on. Okay, well, how do we find that nth term rule then? So here we've got a sequence 6, 12, 18, 24, 30. Now our first step is to find the term to term rule. So that's how do we get from one number to the next number. So the term to term rule, from 6 to 12 we add 6, 12 to 18 we add 6, add 6, add 6. So our term to term rule is add 6. The second step then is that number tells us how many lots of n we need. So that's telling us what we're going to multiply the position number by, because it's following the 6 times table. Okay, so we simply put an n after our term to term rule. Our next step is to write out the first 5 terms of this new sequence 6n. So remember, the first 5 terms are if I swap n for 1, then 2, then 3, then 4, then 5. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and 6 times 5 is 30. So we've taken our new rule and we've written out the sequence, the first 5 for that rule. Step 4, we're going to compare the two sequences. So looking at the first number, they're both 6, then 12, then 18, then 24, then 30. So in this case, they are the same. So as the sequences are exactly the same, then the nth term rule is 6n. We've found it already. You might want to pause the video and make sure you've got a note of those 4 steps before we move on to some more practice. Okay, we're going to do a couple more examples to make sure we understand those steps. So our first step, the term to term rule. So we're looking to see what the number changes by each time. Now this one is going up by 4. So we write down 4. So it's a positive 4. I don't necessarily need the plus in front of a positive number. Our second step is we put an n after it. Okay, so that's telling us we're going to do 4 times our position number. Our next step is to write out the sequence for this value, so 4n for the first 5 terms. So swapping n for 1, then 2, then 3, then 4, then 5. So 4 times 1 is 4. 4 times 2 is 8. Then times 3 is 12. 4 times 4 is 16. And 4 times 5 is 20. Our next step was to compare the two sequences. Now we can see they are not identical this time. So I need to see what's different about them. So if they're not the same, how do we get from 4n to the one at the beginning? Well, I have 4 and I'd like 5, so that's plus 1. 8 to 9 is plus 1. 12 to 13 is plus 1. So we can see that to get from my sequence to the one we'd like at the beginning, we have to add 1 to every number. And so we put that at the end of our rule. So the nth term rule for this sequence is 4n plus 1. Let's do another one. First step, find the difference between each number. So this time we're going down by 3 each time. So going down by 3 means we're subtracting 3 each time. So subtract 3. Put an n after it for our position number. Write out the sequence for minus 3n. Remember, we're swapping n for 1, 2, 3, 4, and 5. So minus 3 times 1 is minus 3. Minus 3 times 2, minus 3 times 3, minus 3 times 4, and minus 3 times 5. So we've written out the sequence for minus 3n. We compare it to our original sequence, and again we can see they're different. So if they're not the same, how do we get from minus 3n to the one at the beginning? So how do I get from minus 3 to 10? Well, to get from minus 3 to 10, I would have to add 13. Let's check the second one. From minus 6 to 7, I would also have to add 13. Add 13, add 13. So again, we always check it's the same for each one. And we put that number at the end. So our add 13 goes at the end. So the nth term for this sequence is minus 3n plus 13. Make sure you're happy with those 4 steps before you move on, and we'll go on to do some practice. Okay, so your turn now then. So you've got 3 sequences here that you need to work out the nth term rule for. So pause the video, go through the 4 steps for each one to find that nth term rule. Have a go now. Okay, so for our first one then, first step, find the term to term rule. So we're going up in ones. Okay, so we have got 1n. Now, often if we have 1 times something, we don't need to write the 1, so you'll see that written as just n. Let's write the sequence for n then. So remember, we're placing n with 1, 2, 3, 4, and 5. So n is simply 1, 2, 3, 4, and 5 this time. Compare it. To get from 1 to 5, we add 4. 2 to 6, we add 4, add 4. So we put our add 4 at the end. So the rule is n plus 4. Our next sequence then, we can see we're going up in 2s. So that's 2n. Let's write the sequence for 2n. 2 times 1 is 2. Then 4, 6, 8, and 10. We compare it. To get from 2 to 0, I'd have to take away 2. From 4 to 2, I have to take away 2. Take away 2, take away 2. So I put take away 2, subtract 2 at the end. Our next one then. This one, we take away 4, take away 4, take away 4. So it's minus 4n. Let's write the sequence for minus 4n. So minus 4 times 1 is minus 4. Minus 4 times 2 is minus 8. Then we times it by 3, we get minus 12, minus 16, and minus 20. Now we compare them. We've got minus 4 and we'd like 18. So if I count from minus 4 up to 18, I need to add on 22. We check for the next one. From minus 8 to 14, I need to add 22. And the next one, I need to add 22. So once you've checked a few of them, then we can put add 22 at the end. Make sure you're happy with those. If you've made any mistakes there, just go back and have another look. Okay then, so finally for today then, our challenge question. So you're asked to work out the nth term of the arithmetic sequence. So remember, an arithmetic sequence is telling us we're going up in equal numbers by adding or subtracting, and you're asked to work out the 100th term. If you want to, you can pause the video now and have a go on your own, or you can work it through with me. Okay, so we've got this sequence and we know we've got to go up in equal steps because it's arithmetic, and we know we're either adding or subtracting. So the numbers are getting bigger, so we must be adding. So we've got to work out what number is halfway between. So halfway between 18 and 36 is going to be the number 27. And to get from 18 to 27, we must have added 9. So we must be starting with the number 9. So our sequence should read 9, 18, 27, 36, 45, 54, and 63. So remember to find missing values. We did this a few lessons ago. If there's one gap in between, then we need to find halfway between our two numbers. And once we've found that, we can work out how to get from one number to the next number. So we've now got our sequence. Now we know our sequence, we can find the nth term. So we're going up by 9 each time, so that's 9n. We write down our sequence for 9n. 9 times 1 is 9, then 9 times 2 is 18, 27. Now we can already see, we don't need to do every one, that they are matching. Remember, if they're matching, then that's it. I don't have to add or subtract anything to the end because they're already the same. So the nth term rule for part A is 9n. Part B then says work out the 100th term. So that means we're going to swap n for the number 100. So we do 9 times 100, which is 900. So 900 is the 100th term in the sequence. So although we've only written out the first 7 terms, we can work out the 100th without having to write down 100 numbers as we went along. Okay, well done if you managed to get all of that. Thank you for working through this lesson today then, and we'll see you next time.